what I meant was, I like you, Mary. I like you a lot. I want to ask you a question, straight out, flat out. I want you to give me the honest answer. What do you think the chances are of a guy like you and a girl like me ending up together?
Well, Lloyd, that's difficult to say, and we really don't...
Hit me with it. Just give it to me straight. I came a long way just to see you, Mary. Just, least you can do is level with me. What are my chances?
Not good.
You mean not good like 1 out of 100?
I'd say more like 1 out of 1,000,000.
So you're telling me there's a chance? Yeah!
All right, so we're going to talk about probability today. And there's a lot of different concepts about probability, and it can be hard to think straight about probability. So we're going to try to address some ways that maybe we can go awry, and talk about some different approaches, as well as just define some basic concepts. So let's start by defining those basic concepts. Classically, this idea of a probability experiment, guys like Caldano and Bernoulli talked about probability experiments. And the idea here is that you have some sample space. And a sample space is just the space that contains all possible outcomes, everything that could happen, right? So if you talk about trying to buy a new car, you could buy any car on the lot. We could limit the sample space if there are cars that are out of your price range. You know, what's the probability you select a given car? We can get at a better idea of that by knowing what the sample space actually contains. We'll use some concrete examples here in just a second to hopefully clarify this further. The other idea is that you have what you call an event. An event is the subset of the sample space that you are concerned about. So if there's a specific thing that you want to happen, that would be the event. So we're asking about what's the probability of some event occurring in some sample space. So an event might be buying that particular car, whatever it is, you know, a 2014 blue Dodge. And the sample space would be all possible cars that could be purchased. So the event is that particular thing. The complement is everything in the sample space that is not the event. It's all non-event outcomes. Everything that could happen that is not the event within the sample space. The outcome is whatever occurs on a single trial. So if we're talking about, you know, flipping a quarter, it's a very simple example to understand. Sample space contains 2 possibilities in simplistic terms. Like it could land on the edge, but we're not going to deal with that, right? So traditionally, you think of a quarter can land on what? Heads or tails. That's a traditional American quarter. There are 2 options. That's the sample space. So if someone calls it heads, right, that's the event. They're interested in seeing heads. Now, the complement to that obviously is tails. Now, an outcome is distinct from the event because it's not what you want to happen. It's not the, you know, subset of interest. Rather, it is what actually happens when you perform a single probability experiment. Probability experiment here is a really fancy phrase for basically saying you flip the coin, right? So you flip a coin, and you see what happens, right? Whatever happens on that coin flip is the outcome. Now, it's important to realize that all probabilities, which we call p-values in statistics, a p-value, p short for probability, all p-values are between 0 and 1. And if you think about this for a second, it should make very clear sense. Why 0 and 1? Because we're talking about proportions. And remember, a proportion is the original decimal value you get when you do a division, right? So if I did, you know, 1 divided by 2, I get 0.5, right? I don't get 50%. I get 0.5. That's a probability value. It is a proportion. A lot of times we talk in percentages. You'd say 1 out of 2 is a 50% chance, but you actually had to do an additional conversion there. You took 1 divided by 2, which gives you 0.5, and you multiplied that by 100, which moves the decimal place 2 spaces to the right, causing it to be 50%. So in statistics, we often don't talk percentages, we talk proportions. So probabilities naturally exist between the values of 0 and 1. 0 being that basically it is not going to happen, 1 being that it must happen. When you think about it, if you put together everything in the sample space, right, the idea that something in the sample space occurs is a perfect probability, right? 1, because it's everything that could happen. So then when you sum the probability of an event with the probability of its complements, right, you have to get 1, right? So what's the probability of the event heads? 0.5. What's the probability of the complement to the event tails? 0.5. What do you get when you sum 0.5 and 0.5? 1, right? So the probability that a quarter comes up either heads or tails would be 1, right? That's everything that could happen in the sample space. Okay, so these are some of the basic terms. If we think about this in an example like rolling a die, right? Or if you want to use dice, technically it's acceptable as a singular or plural nowadays. So if we're going to do this, like if we break down the pieces, the sample space for a traditional die that you would see is 1, 2, 3, 4, 5, 6. That is, those are the things that can occur, right? Everything that can occur when you roll a die. You could get one of those numbers on a traditional American die. So if I'm interested in rolling an even number, then my event would contain the values 2, 4, 6. The complement then would be 1, 3, 5. So then if I actually roll a die, whatever comes up is the outcome. So in this case, 3. So here we see that if I think about the sum of the probability of the event and the sum of the probability of the complement, I come up with 1. You know, there's a 100% chance that a number, 1, 2, 3, 4, 5, or 6 will occur. Right? Notice I said or. So this is an important concept, some of the basic definitions when it comes to probability.